Hey guys, this is Ivan from PARSIQ, and we are starting our workshop on the Tsunami API and SDK. And today here with me is Metis. Hey Metis.
Hey, Alan. Hey, everybody.
Yeah, so before we proceed to the actual demo, let us show a few details, share a few details on what we're going to do today. So this is the Unicorn Workshop number 2. We're thrilled to have you here today as we dive into the world of PARSIQ and explore how our tools and solutions can empower blockchain events and developers. We've got an exciting agenda lined up for you, packed with valuable insights and practical demonstrations. So let's get started, and over to Emilis.
Yeah. Hey, guys, again. So first thing first, I guess, wanted to share some exciting success stories of projects that have already benefited from PARSIQ's data lakes or custom-built APIs, as we call them. So, just want to share a few real-world examples of how our custom Web3 data APIs have made an impact on different teams from different backgrounds. And it's important to know that these projects chose to have their data lakes built by our team. So they trusted us in the whole process. But what's even more exciting is that as devs, as developers, you have the option to use our SDK to build your own custom data solutions. And that's what we're going to explore in detail today. But before we dive into those aspects, I guess we can start with some basics just to cover those people who may not be very familiar with PARSIQ. So, Ivan, I'm turning back to you. Can you tell our audience what's the difference and what actually are the Tsunami API and SDK? For what use cases are they useful? And yeah, just the main differences, so we can then jump into the workshop better prepared.
Yeah, sure, with pleasure. So PARSIQ Tsunami API is like the bridge to the blockchain data. It allows you to retrieve raw blockchain data and think of it as your gateway to the vast world of blockchain information. Now, you might wonder, why do we need SDK if we have API already? Well, our SDK is your toolkit for accumulating, processing, and storing this blockchain data. It's the engine behind building custom data solutions tailored to your project's unique needs. To help you get started with SDK, we'll walk you through the setup process, and we want to make it as accessible as possible, so don't worry if you're new to this. And today we're going to build an allowances data lake. This data lake will allow you to track the wallet balances and allowances efficiently. We'll cover how to track events and calculate balances. We'll delve into tracking function calls because we will need that for that particular purpose, and that's a bit of advanced thing. And yeah, extracting message sender details that might also be useful for some other use cases. And it is crucial for calculating allowances. As we go through this, remember that the SDK is a versatile tool. Its applications go beyond what we'll cover today and beyond the use case that we'll discuss. It's all up to you. So yeah, be ready to explore its full potential. And now let's share a few real-world use cases with our listeners today. So over to Emilius again.
Yeah, thank you, Ivan. So I guess we can start with a gaming project that those of you who have been following PARSIQ may have heard about before. Their name is Block Cave Scissors. So they're a gaming studio in the blockchain gaming space, and their goal was to merge traditional gaming blockchain tech to enhance user experiences and obviously inclusivity that comes along with blockchain. But then, as they grew and integrated with the blockchain, they faced some critical data challenges. One of them being slow on-chain data retrieval and also resource-intensive in-house development. And those two things were hindering their progress. And this is where PARSIQ had a chance to step in. We did collaborate closely with the team at Block Cave Scissors and created a custom data solution for them that specifically addressed those two issues: slow on-chain data retrieval and a lot of time spent on custom development. So the end result was that it significantly improved player experience, and the core of it was this low latency API for quick data retrieval. It also offered reliable Web3 data indexing because reliability is obviously crucial for most dApps and projects in the space. And also, it sort of eliminating the need for them to build something in-house where they're not as strong. So they know really good, they have really good basis in terms of gaming, but data is something that not everybody can do well. And also, actually not all, we also ensure the user privacy by abstracting account IDs, allowing block ape users to link those IDs with in-game NFTs without revealing wallets. This was one of the game-changing features for them, actually, because it's also a huge bonus for privacy reasons. So, the whole thing saw remarkable benefits from our collab. They achieved vastly improved UX, I would say. Obviously saved a lot of money in the process and preserved privacy. Another good example is VirtuSwap. Again, a close partner of ours. They're a decentralized exchange with a vision to offer lower trading costs, but also focused a lot on liquidity providers. So they needed a real-time, low latency solution to retrieve data again. A challenge that, well, other providers couldn't fully meet, or if they could, then the price tag would result in some really huge numbers. So PARSIQ's Tsunami API and ABI decoder that goes hand in hand with Tsunami API, it came to the rescue in this case. It provided VirtuSwap with something they really wanted. And the end result was that VirtuSwap was able to ensure lower trading costs and higher returns for liquidity providers, because liquidity provision is something that is still being not addressed properly among different decentralized exchanges. And I guess finally we can mention Crypto Orange. They're a cryptocurrency exchange. Well, at least one of their verticals is. And for compliance reasons, they need to monitor risk scores of not only incoming transactions, but also outgoing. And the beauty of data lakes, as opposed to, say, subgraphs, is that developers can combine on-chain and off-chain logic. So those risk scores, essentially, it is not data that can be found on the blockchain, on the block of the blockchain. It's actually off-chain data that, well, it's derived from on-chain data, but you cannot find the risk score, let's say, taking a look at the block information on Ethereum. So the data lakes can be set up in a way where off-chain data can be built in the data lake, so that the end user gets exactly what it needs. It also widens the potential horizon of our potential clients and partners. So with those use cases in mind, I think, Ivan, is now a good time to really start the workshop. And in this case, I'll let you show how to build your own data solutions, especially when it comes to, in this case, building a data lake for allowances. What do you think, Ivan? Should we begin?
Yeah, this makes sense. Thank you for the intro on the use cases, Metis. And now let's dive into our tech. So first of all, I will share my screen and show you guys how it works. So present. And yeah, Metis, please let me know if you want to say something. For now, I will be removing you from this screen. Okay.
Sure.
Okay, guys. So here's our demo, and let's take a look at the code. So basically, I've shared with you how to create a simple voting data lake on the previous workshop. So in case you're interested, please check out our YouTube channel and see the previous workshop. And today we'll be taking a look at how to build an allowances data lake. So what is it and why do we need it? Allowances data lake is going to show us the balances and the allowances for the address of interest. And it's pretty obvious why we might need balances, but also allowances is an important thing as well. So whenever you're interacting with DEX, you're allowing this DEX or other DeFi project to spend your funds by calling the approve function of the ERC20 token. And after that, this DEX or this smart contract can call a transfer from function and transfer funds from your address to some other address, let's say to the address with which you are exchanging, right? You might have some allowances for some of the contracts that you interacted in the past with, and you might be not aware of this thing. So basically our example data lake, which is like not a production thing, but it still might be useful even for that purposes. So yeah, in order to calculate balances and allowances, we will need to accumulate the data and process it. That's why we need SDK. Let me show you first how it would be done with raw data and why this is not enough. So before we proceed, let's go to PARSIQ to get our API key. So I'm already logged in here. Let's regenerate the key, get the new one, and put it to our Postman. So basically, this is a Postman collection. You can also get it and download it, and we'll share it in the description of the video after the workshop ends. Okay, so I put my API key here, and let's run some test call. So basically, here I'll be taking a look at some signature hash of the function of the transfer from function, I believe, if I remember correctly. I will be getting this function calls from the blockchain. In our case, this is Sepolia testnet, because like all the example I prepared, it's on Sepolia testnet, and we'll be working there today. And this is basically my address for which we've built the data lake as well. So let's run this request, right? And you can see what we get here in the data. We get all the raw data that we need. We get the sender of the transaction. We get its signature hash by which we've filtered it. It's the signature hash of the transfer from function in that case, and all the other data, such as the hash of the transaction and so on. But we are not satisfied with that, because we don't need just raw data. We need to go through the whole history. We need to see all the transfers, and we need to see all the transfers from and approves. And then we will need to take all that into consideration to understand how much tokens do we have and how much allowance do we have. And to do that, we will need SDK, because SDK allows us to work with the data. Basically, it requests the data from Tsunami the same way I showed you here. But after that, it processes it. And let me show you how. So this is our project Web3 API examples. You can clone the project from GitHub. The link is in the description of this video. And currently it has 3 examples. The first one, which is CNS registry, the second one that we've built on the previous workshop, and the third one that we're going to discuss today. And this is our allowances data lake example. So basically, if we're talking about the project that we're going to compile and run, these 3 projects are in 3 separate folders in this repository information that is in README, right? So let's go in our folder, which is allowances example. We have a README here as well. So to run it all yourself, you can just follow the instructions. All the code is ready to go. The only thing you will need to change to run it is your API key. And let's go here to data lake src, data lake ts file, and change this API key. Again, let me go to my dashboard here. Let me regenerate the API key. And let me copy paste it in my code, right? Okay, so I think the best way to structure this workshop will be basically to go through the whole file, because basically this one file describes all the logic of what we're doing today. And after that, we'll run this data lake to make sure that everything works as expected. So API key done. The next thing is the network that we're going to work with. In our case, it's Ethereum Sepolia. And yeah, that's it. So the next thing we need to specify. So basically after that, we are doing our stuff. So it depends on the particular use case you're implementing, on the particular data lake you're doing. So in our case, it's the wallet address of the wallet that we're gonna monitor for balances and allowances. So also we need a contract address here. And this will be the address of the token that we'll be monitoring. And this is wrapped Ether on Sepolia testnet, right? We will also need it in lowercase. I will later show why. Then we will need to get the topic zeros of the events that we're interested in. And topic zeros, you can find them on Etherscan, you can find them in Tsunami response. They basically specify the event that you are taking a look at. Yeah, and one thing I somehow skipped, which is pretty important, is importing the ABI of the contract, because obviously to interact with the contract, to read its events and function calls properly, we'll need to know its ABI. So I have this wrapped Ether ABI here in a separate file, and I import it to the ERC20 ABI. Okay. The interesting thing is that wrapped Ether is a bit different to ERC20 because it also has deposits. That's why I needed to use wrapped Ether ABI, not just ERC20, and we'll talk about that later too. So yeah, we have the transfer event, topic 0, right here, approval event, and deposit event. These are the 3 types of events that we'll need to calculate what we need correctly. And the other thing that we'll need is transfer from signature hash. So the signature hash of the function basically specifies the function that you are calling. It like more or less does the same thing as the topic 0 for events. And but it's a bit less common, so you might have heard about it or not. Anyway, we have an example on our YouTube channel on how to get signature function hash using Tsunami API. So in case you need it for some other function, you can watch this video as well. All right, and then we don't want to go through the whole blockchain, through the whole history. So I just specified the block at which I started using this address so that we will see all the activity right away, just after starting the data lake. Okay, so these are like basic and simple things. And now we are going to a bit more interesting stuff, which is storage layout. So in our case, it's pretty simple because we're just calculating balances and allowances. And all the other stuff I have here, I created it for development purposes to see what events are being tracked correctly, basically to debug my own code. So we don't need that. But here I decided to leave it for educational purposes because you still might need that for debugging purposes, right? So also we have the storage meta layout, but that's for more complicated use cases. In our case, we don't need that. We just need balances and allowances, and with balances, we'll be tracking addresses and balances, which are numbers, and addresses are strings. And with allowances, we'll have owner-spender pair as a key, right? It will be a string, the pair of 2 addresses, and allowance, which is number, as a number. All right. So these are our main databases. These are our debugging databases, which we don't need. And the next thing is processing events. So we'll be monitoring transfer, approval, and deposit events on the blockchain, and we'll need to do something with them. And to do that, we'll need to decode them. And here is how we do that. We specify the TypeScript types for the corresponding events. So for transfer event, so the names are the same as in wrapped Ether ABI. Basically, it's the from, it's the to, it's the value for transfer. It's the owner, it's the spender, it's the value for approval, and it's the to address and the value for deposit, because basically deposit happens from 0 address. It's like a transfer when wrapped ethers are minted, though they don't really call it mint as far as I understand. Yeah, and since they don't emit a transfer event when they deposit funds initially, like when you put your ether into wrapped ether smart contract, they give you wrapped ether, which is an ERC20 token equivalent of ether, and they don't fire a transfer event at that point, but they do fire a deposit event at that point. And that's why we need deposit events, because in order to calculate your balances correctly, we will need to take into account deposits as well. All right, so most of the code from now on is reusable. So we will be taking a look only at particular places that you will need to change for your use case. And the rest, it's basically a boilerplate project. You can reuse most of the stuff, right? So here we're importing the API that I mentioned before. Here we specify the start block number. And here we specify topic zeros that this data lake will be monitoring on this contract, right? So with this example, it's super basic and super simple. We're doing just one wallet for one token. It's like the wallet with wrapped ether. It has some testnet Uniswap tokens as well, but today we won't be taking a look at them. We will be taking a look only at wrapped ether with this data lake. Okay, so then whenever a particular topic zero is met, a particular function to process this event is called. So let's go, I'd say, from bottom to top, because it will be simpler this way, because transfer is the most complicated thing like in this process, right? So first of all, how do we process deposit events? So topic zero deposit appears, process deposit event function is called. Then we decode what we have here into the deposit event. So we get this event by topic zero, we decode it. So make sure that here you have the same number of the arguments as you have indexed arguments for this event. And yeah, I guess we'll need to take a look at the event. So to understand what's happening here. So this is basically Etherscan page for my address that we'll be taking a look at. And basically this is this is 34 years ago, the moment you can see this block when we start this data lake. So we're not interested in all the activity before, we're only interested in the activity with wrapped ether, and I only started it at this point. So yeah, let's take a look at the deposit event, let's say, and let's so you know, like all the basic information about the transaction. Let's take a look at the logs. So you can find the topic zero right here, right? And here you can see which arguments are indexed and which are not. And the same you can see in the code, basically. Yeah, so make sure that here you have the same, you have just the indexed arguments. Okay, so we've decoded this event. We have this deposit event here. Then we get the to address like this. So since we specified this event here, deposit event here with DST and WAD for to and value, DST is basically the to address. So we have, deposit event. So we have the to address here. And if the to address of the deposit event matches our wallet address, then we process this event and put something in the database, because we're only interested in deposits made to our wallet. Okay, so here we have the value, and then we just go to the database, the deposits database, and create a record there. So it's the one that we're using for debugging purposes, so that basically might be skipped. We just putting our deposit event there. So how do we do that? We're using this thing, which is a transaction hash, as a key. And we're using to and value as a value, right? Let's go further. So we also have balances here. First of all, we need to check whether we already have a balance record for this address. So we are trying to retrieve it from the database, balances for this particular address. And since we're storing all the stuff in the database with addresses in lowercase, we are also converting it to lowercase here. And so if we have this balance, then we update it by increasing the balance by the value, right? And then we store this balance back in the database. And if we don't have this balance, then we just create the record straight away with the balance equal to the value, because this means that there was no balance. The balance was 0, so now it's value, right? So this is how the deposit event is processed. So whenever there is a deposit event on the blockchain, we update the balance for our wallet by increasing it with the value of the deposit, right? So that's pretty simple. Now let's talk about approval events, because here we're not only interested in balances, we're only interested in allowances. And in order to calculate allowances correctly, we will need basically two things. The first thing we'll need to set these allowances whenever there is an approval event, and that's what we're going to do here. And the second thing, we're going to decrease those allowances whenever there's a corresponding transfer from the owner address to the spender address, like of some value. And then we'll decrease this allowance by this value if it's not infinite. So we'll see it further. Right now, let's just talk about approval events. So same as before, we're decoding the event. We're getting the owner, which is SRC for this event. And if the owner of the funds that are approved for spending is our wallet, then we're interested in this event, and then we are doing our actual logic here. So we get the spender, we get the value, we store the event in approvals table for debugging. Then we store the allowance. So first of all, we create the key, owner spender key. It looks like that. It has the owner address, it has the spender address, and then it's lowercase, right? Probably it might make sense to not to create a key from owner and spender, but to create a two-dimensional array and store it that way. But for this particular example, we decided to go the simplest way, and this is the simplest way. Just not to give a lot of stuff at once, right? Okay, so if this allowance is there, right? If we already are tracking the allowance for this owner spender pair in our data lake, then we update it. So here we don't increase it by value. Here we set it to value due to the logic basically of how approve works, right? You can see it in the smart contract code and store it in the database. And then if we don't have this allowance, we set this allowance to the value. Pretty straightforward. Okay, so the last thing we need to discuss here is the transfer event. And as you can see, the function is a bit bigger here. So this part, it's about updating allowances. And this part here is about updating balances. So like if we were only to update the balances, then we would have just this, but we also need allowances. So we'll go through this whole code. Okay, so let's start from the beginning. Here we have the same thing as before. We are parsing this event into our transfer event. Then we go for from and to addresses. And we are starting our logic in case either from or to address is our wallet address, because in both cases, the balance is going to be updated. Okay, So we are getting this value, and we are storing our event in the transfers table, also for debugging. So we don't need that in production code. And yeah, the next thing we do is we set the sign here. So to avoid copy pasting additional lines of code and making code bulky, I decided to do it like this. So if it's from, then it's -1. If it's to, then it's +1. Then we're getting this balance for this address. Yeah, and if it was already there, then we are increasing this balance by the value. So TypeScript does a bit of type magic here. So I needed to explicitly convert balance to number, though it already was a number. So in case you see something like that, like know about this tip. And yeah, and after that, we are basically storing it in the database. And yeah, the sign is also working. So if it's from, it's decreasing the balance. If it's to, it's increasing the balance. Yeah, and also we have, like in case we didn't have this balance, we put it here. So I might say that we have an issue here, because in case we start our data lake at the wrong block, we might see negative balance. So I haven't added a specific error handling clause here, because I knew that I was only going to use this code like as expected, so that the balance will first increase and then it will decrease. But yeah, if you're going to implement something similar, make sure to handle this situation here as well. Okay, so at that point, the balance is updated and everything's smooth with balances, and we go to calculating allowances. And with allowances, it's a bit more tricky, and I might even need to... yeah, I don't think I will need the smart contract code now. I think I will go with this. But yeah, so the allowance is updated when no, I think it's better to show you the transfer from function as it is, right? So let's go to standard implementation of ERC20 smart contract, which is OpenZeppelin. And let's take a look at the transfer from function here, right? Yeah, so as you can see, sorry, it somehow put me to a different place. Where's the trans from? Yeah, it's here. So yeah, whenever there is a transfer from, we need to update allowances. So you know what's happening here. We get in the spender, and basically the spender is a message sender. So message sender is different from the origin of the transaction, and that is crucial for our example and for allowances in general. So let's say you are interacting with the DEX, and you are trying to make a swap. In that case, the first transaction you will send will be the approval transaction. So you will approve funds for your wallet, for the DEX to spend funds from your wallet. And on the second transaction, you will be initiating the swap itself. And when the swap happens, you interact with a DEX contract, and DEX contract is interacting with your token contract, which in our case is wrapped ether contract. And DEX contract is calling transfer from function to transfer funds from your address to the address of interest. So it might be the counterparty with which you are actually exchanging, or like the pool or something else, right? And in that case, the to address, it's different from the DEX address. So the smart contract that is calling transfer from function is actually different from the to address. The funds, in most cases, they go to some other place, to another smart contract, like to the pool smart contract, or to the counterparty or to some other place. So this too is not the spender. The message sender is the spender. So the funds, they're going from your account to some other account. And we need not this address to calculate the allowances correctly, but the spender address, because the allowances, they are like not about where your funds go, but they're about which smart contract spends your funds. So in this case, it's like in every case, it's the spender. So it's message sender. So the message sender is the entity. In our case, it's a smart contract that's directly calling this function. In our case, it's transfer from. And yeah, after that, we spend the allowances, which is pretty straightforward. So basically, that's what I needed here to show you that spender is a separate entity here. So we'll need to get the message sender. And now let me show you how we'll be getting message sender using PARSIQ Tsunami API and SDK. So at this point in code, what we have, what we are processing is this transfer event, right? And like if we look here on Sepolia Etherscan, for instance, yeah, let's go to see all the transactions that we have here. So this deposit transaction, I'm spending my 0.3 Ether, and I'm getting some wrapped Ether. So there is a deposit to this address, which is my address, of this value, which is 0.3, right? The next transaction is I approve these funds for some other contract, for the DEX contract, basically, Uniswap. So this is topic 0. This is the source, which is the owner. This is the guy, which is the spender. So this is the smart contract that will be spending my funds. And this is the value. And this is the value of wrapped Ether at this point, not Ether, right? Okay, and then there is an execute transaction. Let's also take a look at what's happening here. So some wrapped Ether is being spent and being transferred, and some Uniswap token are being transferred. Okay, so let's go to this transfer event of the wrapped Ether. So this is the wrong smart contract. This is the Uniswap token smart contract. And this is the right contract. This is wrapped Ether smart contract. Let me show you. Yeah, wrapped Ether. Okay, so that's the transfer event from my address to some other address of this value. And on the other hand, there's a transfer from this address to my address of some Uniswap token. So basically, that's the swap, right? And as you can see, yeah, that's what I wanted to show. As you can see, we don't have a transfer from event here because there's no such thing as transfer from. And as I have said, at this point in code, where we start processing allowances, we just calculate the balance, process allowances, we were processing the transfer event, right? So at this point in code, we're here, we're working with this thing. And this thing does not know anything about transfer from, about the spender, or about other stuff. So we cannot get the spender from this event. It's just not there. So in order to get the spender, we will need to get the transfer from function call, and from that function call, we'll get the spender. That might be a bit tricky, but that I would say is the most complicated part of the today's workshop. So if you understand and handle that, then basically you got everything right. So yeah, what we're doing here, we only have the transaction hash, the contract that we're interested in, the signature hash of the function. So we don't. So we need to find that call, that function call, before we work with it. How do we do that? So first of all, we get the whole transaction. Since we know the event that was triggered in this transaction, we know the transaction of interest, we know its hash, so we are getting its hash. After that, we are starting a Tsunami client within this data lake to separately get this particular transaction. And we're doing it like calling this method get transaction with logs. We getting the transaction by its hash, right? And after that, we want to get the message sender. So to do that, we go through all the logs of this transaction. So this is the transaction. It has its logs. And its logs, basically, you can see them using our get transaction with logs endpoint. You will see all the events. You will see all the function calls there. And you will specifically see whether its opcode is event or call. And currently, we're interested only in calls because we're looking for transfer from call, right? So we're iterating over the calls in this array of logs of this transaction. And for each call, we are doing the following thing. We are checking whether it's the right call. So to make sure it's the right call, we need to make sure first that it's the call, not an event, because like here, despite I've named this thing call here, because it's gonna be a call, this whole array here, it has both calls and events. So here we're checking that we are in this iteration, we're dealing with the call. Also, we are making sure that we are taking a look at the call at the correct contract. And here we need the contract address lowercase. And also we make sure that we talking about the correct transfer from call, and to see that it's a transfer from call, we need to make sure that its signature hash is transfer from signature hash. And then if it's the right call, then we get our message sender and break out of the cycle, right? So with this message sender, we go to updating allowances. And this is what we do. We get our key first, as I have previously mentioned. Then we are getting the allowance entity from the database. And here we're not talking about the case when we don't have one, because like if there is no allowance, then this call would not even happen, right? So here we don't really need to work with the other case, but like in case you're not sure that you'll be going through the whole blockchain and you'll be going through the whole events and you might miss some of them, in that case, make sure to like work with all the things that can happen. Okay, so when we have this allowance, here we make sure that it's not the infinite allowance, because with infinite allowance, we don't need to decrease it even when some funds are spent. So if it's not the infinite allowance, in that case, we are updating it by decreasing it by the value of our transfer from call or our event. And basically, these values would be the same. And after that, we store this in the database. And basically, that's all that happens. So let me show you that I've shown you all the code. So we've gone from the top. We've discussed this. We've discussed that. And we have some more code in the end that we didn't discuss, but basically you won't need to update it initially. Only here, make sure to list your databases here. And yeah, now let's run it. To run it, let's go to our README. So basically, to run it, you might want to npm install it, though it's not necessary to run it. It will be just more comfortable to work with, so that all autofill works. Also, you might need to install Docker. I'm working on Ubuntu virtual machine here, and I'm working with Docker, not Docker desktop. On Windows, you might work with Docker desktop. So it should work with Windows. I tried it, but it might need some tweaks. So in case you're only interested in working on Windows, please talk to us, and we'll tell you about the tips on Windows. Out of the box, it's supposed to work on Ubuntu, which it does. So I've already installed Docker, and I just need to run this thing here. So make sure to be in the right folder, because the folder of the GitHub project is the mother folder for the 3 folders of separate data lakes. And in our case, it's allowances data lake, right? And we'll be running building here. Okay, so it is there, successfully built. And now let's run it. Yeah, so it's creating the container. Yeah, and now it's up, and the database is ready to accept connections. And now it starts to process the blocks. So it starts processing the block from the block that we specified. It will go through the whole history. It will need some time for that, because like it's 34 days ago, I guess. But after that, it will start processing the events in real time. So data lakes, they work both for historical purposes and for real-time purposes. And like here we have a database. You might connect, for instance, your dashboard of your application to this database and show your clients their balances and allowances, or whatever you need to track in your own project. Okay, so something's happening here, but we don't know what, because we haven't looked at the database yet. So let's do that. While it's still running, because the database obviously is up only while it's running, we run this command here. Sorry. Okay. Yeah, first let's see the databases that we have. A bunch of them, because I created additional ones for debugging purposes. So in fact, it will be less of them. So it will be allowances, entities, allowances, mutations, and also blocks, balances, and that's it. It won't be approvals here, deposits, and transfers. Okay. Now, since we're interested in balances, let's take a look at the balance. Okay, so we have only one balance here because we have only one address, and its balance is this, right? I believe it's like if we go through the decimals, 1, 2, 3, 4, 5, 6. It's 9, it's 12, it's 15, it's 18. So basically it's 0.147 and so on. So let me check this on Etherscan as well. Yeah, so this is my address on Sepolia Etherscan, and this is our wrapped Ether, yeah, 147. So as you can see, the balances were calculated correctly, right? And now let's go here to our allowances. Okay, so we have this owner spender key here, and owner spender is here as well. And we have allowance, and it's 0. And in fact, it's correct. Let me show you why. As you have seen, I have approved some funds here, and I have approved 0.3, right? And then I have transfer from some funds here by this transfer, the same amount. So basically, we spent the whole amount that we approved. Now, how do we make sure that our allowances are calculated correctly? Yeah, so first of all, I have already made sure for you, so you can just believe me. then you can pause the process. Like if you work with this data lake, you can pause the process after some block, after the block of approval, but before the block of spending, and make sure that it's there. Yeah, and also just the very fact that we have an allowance record in our allowances table means that we processed the approval event correctly, because as you have seen, we're monitoring approval events and only creating allowance recordings when there is an approval event and it's processed. So there was an approval event, it was processed, and it created some allowance, and this allowance was 0.3. And since now it's 0, it means that the transfer from thing with reducing allowance worked as well. And you can check this by adding some additional pauses here, or just by running data lake up to some specific block. Yeah, basically, I believe that's everything that I wanted to share today. So let me recap what we've done. We've gone through how to create, set up, and run a data lake for balances and allowances with our SDK. And also, I want to tell you that SDK can be used for any use cases. So it's only up to you. It's not only for balances, allowances. It's for anything that needs processing. So whenever you need raw data, such as events, function calls, and so on, you might go just for Tsunami API and get all the data from there, and after that, process it on your end. But in case you need something that accumulates data, calculates some stuff, applies some logic, be it voting calculation or TVL calculation, or maybe you have your own project with some specific stuff there. So like, as you can see, it can be done, it can be calculated, and you can give it to your users or just use it in your pet project pretty easily and quickly. And yeah, that's it. Let me go back to not sharing my screen, and let me invite Emilius back here.
Yeah, man, that was a really good job. Tremendous effort. I think we have one technical question in the chat from Jamie. Perhaps you can address it.
Yeah, so what is the type of TX logs? Jamie, thank you for the question. It feels great to know that you guys are listening closely. So let me share my screen and take a look at the code again. TX logs. Yeah, so TX logs, it's the array of these calls, and the type of the calls is transaction log. So basically, it's our internal type, and I don't know how to jump straight from here to it. No, it's not the definition of the type. Yeah, unfortunately, I cannot show the definition of the type right now, but it has some of the stuff in it. Let me show you what exactly. Yeah, it has all these things about the call. These things, they differ on whether it's a call or an event, right? So we might have different fields for calls and events. But here you can see like the contract, the ID, the input data. So basically, it's structure with all this data. Opcode, origin, output data, sender, signature hash, and yeah, topic 0 for the events, and so on. So yeah, answering in short, it's transaction log, our internal type. Okay, so we have another question here. And it's iOS Windows, please, any useful links to get started? Yeah, so I would say the useful links would be the same. the main useful link would be the one you can find in the description of this video, which is to the GitHub of this project. And yeah, I think the only difference that there is on Windows, so since it works differently a bit with characters on the command line, some of our scripts don't run as expected, as they don't drop the table at the restarting of the data lake. So it needs to be a bit updated. Please contact me in our chat, and I will let you know how exactly, because we've already done it, but we decided not to share it with the public because it wasn't like a very solid solution, because basically it deals with some magic that happens with Docker on Windows. That's why it can't really be made very solid. Okay, and the next question is by Jan Medford. I'm convinced on the tech. You guys are the only microcap I hold, but can you speak to the marketing plan at all? Because everyone I can convince to actually get eyeballs on the project buys a bag. And this one goes to my friend Metis here.
So I guess we'll take it as a compliment that you're convinced of the tech, because PARSIQ being a developer-focused company, that's the biggest goal we have, is to cater for developers to help their life be easy when it comes to accessing, processing, utilizing blockchain data. Price action is obviously something. This is not the topic of today's workshop. However, be assured that the marketing team is looking at what can be done to spread the word on PARSIQ. And once we have a next AMA with people from marketing department, feel free to ask the same question. We're open to any criticism, questions, or feedback. We're there to listen. And having said that, to everybody that's developing or planning to develop using this SDK, feel free to reach out to us to talk. Should you need any assistance, we'll be happy to give some guidance. And just in general, PARSIQ is there to collaborate. So you can easily find us on socials, on Discord, on Telegram. Just let us know that you're building with an SDK, and feel free to reach out. We'll be there to assist and to just work together. Ivan, are there any other questions?
Yeah, I guess there are no more questions. So there are some words. So Jamie was curious about opcode. Thanks, that was helpful. Yeah, thank you, Jamie, for the question. Dennis, yeah, I will share my Telegram handle in the chat. And please contact me if you start. And make sure to contact me if you start working with that on Windows and meet any issues. Just write me in the Telegram, and I'll share with you the what will help. And I've shared it in the chat. And yeah, no more questions. I guess that's it for today then.
Yeah, it looks like we're right on time, 1 minute past an hour limits. So I guess it's a good time to drop off for us. Thanks for tuning in, and for everybody else who will be watching the recording. I can only repeat myself. Feel free to reach out, and let's see what can be done. I guess it's a good time to say Merry Christmas to everybody, Happy Holidays, and thank you for staying with us. Thank you for following PARSIQ. We're looking forward to exciting 2024.
Yeah, thank you guys very much. It's been a pleasure to present to you. Merry Christmas and Happy New Year. And Emilius, thank you for being with me here and sharing this event. It's been a pleasure.
It's been a pleasure myself, Ivan. You did a great job. Thank you, and goodbye to everybody.
Thank you, guys. Take care. Have a good one.